Hey guys, my name is Samoga Simon and I'm from Makerere University. I'm here to present my final term paper, yeah, on the AI surveillance camera. So, giving you the abstract of this project, I'm looking at analyzing video footage. So analysis is going to be taken on the video footages that are going to be recorded. Let me say you have a company and you want people to be recognized. Let me say your workers, and you have a data set of your workers. These workers can be recognized that this is Trevor, this is Simon. Yeah, so that those can be opened for them, or even for security purposes. So that's all about the whole thing. So my uh, maybe I can also talk about the correlation matrices, the metrics I'm going to use. Uh, yeah, we remember we have precision, F1 score, recall, accuracy. All that is going to be talked about. Yeah. So the introduction is here. That is my introduction, whereby uh, the project of an artificial surveillance camera involves the integration of cutting-edge technology such as machine learning and computer vision. So we are bringing machine learning together into the computer vision so that we can improve the security of our environment. So yeah, that's all about the introduction. Then the background and motivation. Artificial intelligence, that is artificial intelligence, it's the development of computer systems that can perform tasks, yeah, using machine learning. Then surveillance camera is a device used for monitoring and recording visual information in specific areas. Then machine learning is a subset of artificial intelligence. Machine learning, we have different categories, supervised and unsupervised, as you're going to see them. Then computer vision refers to the field of study that deals with enabling computers to interpret and understand visual information. And in Python, we use OpenCV. OpenCV is a package that gives the computer the capability to interpret and understand the visual information from the world. Yeah. So we talk about the security threats. We have the background and motivation for this project stem from the increasing need for enhanced security solutions in various settings. Yeah, transformed into intelligent tools that can be used for security purposes in the environment. Then the literature review, we talk about the artificial intelligence, how it's used in recent years. So in recent years, we have seen that AI has been increasing, its use has been increasing throughout the world, and machine learning also, then computer vision. These are all reviews. So overall, there has been a significant amount of research in the area of AI-powered surveillance cameras in recent years, with the focus on improving the accuracy and efficiency of these systems. Yeah. So um, gaps, the disadvantages in existing supervised and unsupervised learning techniques. So both supervised and supervised techniques have their own strengths and weaknesses and are suitable for different types of problems. However, some of the general weaknesses or gaps in existing techniques are overfitting for supervised learning. Overfitting is one of the biggest challenges in supervised learning, which occurs when the model is too complex and memorizes the training data instead of learning the underlying patterns. Then data quality and quantity, uh, feature engineering. In many cases, the raw data is not in form suitable for feeding into a model. Then unsupervised learning, lack of ground truth. Okay, we know that supervised learning deals with labeled data and unsupervised learning deals with unlabeled data. So we can, if you can remember that, you can know what how to play around with their weaknesses. Because unsupervised learning, when you see lack of ground truth, what are you basing on? Once you know that data is labeled, it's unlabeled, then interpreting the results is also hard because the data is unlabeled. Because of dimensionality, that is more complex because with the high dimensional data, where the number of features is large relative to the number of samples, this results into the cost dimensionality, where the algorithms become computationally expensive and their performance degrades. Yeah. In addition to these gaps, there are also some technical challenges facing uh, existing AI techniques. Those are explainability and transparency, robustness and adversarial attacks, scalability, all that. Then the solutions to that, overfitting is to use regularization techniques such as L1 and L2 regularization. You can go back and read about that more. Then for data quality, data augmentation techniques can be used. Then featuring feature engineering, we can use techniques such as feature extraction, feature selection, yeah, feature generation, all that. Then unsupervised learning to address this problem, we can use evaluation metrics such as hold scores can be used. Yeah. Then cast dimensionality, then interpreting results to make more interpretable. You make them more interpretable. You can use heat maps, scatter plots. So for my case, I designed a heat map for just to remove unneeded and unwanted data, such as because we are looking for people's faces. So this heat map is going to enable you see a person's face. It will remove other objects like birds, what. Then yeah. Then when we talk about the methodologies, sorry about that. So the problem being investigated in the AI camera project is how to improve the accuracy and efficiency of surveillance cameras in detecting and tracking objects. So the significance of this problem lies in the increasing use of surveillance cameras in public spaces and the need to ensure the privacy and security of the individuals. So the scope of this project is to evaluate the performance of various techniques in solving the problem. The AI approach proposed for this project involves the following steps: data collection and preprocessing. The first step is to collect and process the data. We know that. Then feature extraction. The next step is to extract the features from the data. Model selection and training. The third step is to select and train the models. Model validation and testing. It's where we test the data. After validating it, you test it. Then model deployment and evaluation. It is the final step where you deploy the models in a real world scenario and you know how they work in the environment. So the AI evaluation framework used in this project involves the combination to perform metrics such as of performance metrics such as accuracy, recall, precision, and F1 score to assess the quality of the results. Additionally, visualizations and explainability techniques such as silence maps and decision trees are used can provide insight to decision-making processes. Yeah, uh, in summary, sorry, So in summary, the proposed AI approach in this project is to use a combination of supervised and unsupervised learning techniques to improve the accuracy and efficiency of the surveillance camera. So we are proposing to use both unsupervised and supervised for improvement of the performance. The performance of the models will be evaluated using a combination of performance metrics and valuation techniques to provide insight into decision making. So, studying your AI, your open data set I'm briefly described. So in the data set I'm using for my AI surveillance camera, important features that the AI model will likely use include object, size, shape, color, and movement because it is a surveillance camera. The model will use these features to identify and track objects in the data predictions and when selecting a data set for an AI surveillance camera project, the following factors should be considered. The relevance of the data set. The data set should be relevant to the problem being addressed. Diversity. The data set should be diverse in terms of objects being detected and the environments in which they are captured. Quality, then the size. So we can conclude by saying when selecting a dataset for an AI, it is important to consider factors such as those we have mentioned above to ensure that the models are trained on data that accurately represents the real-world problem being addressed. So when we look at the data preparation and explanatory data analysis, I prepared and cleaned my dataset manually. Since it is an image dataset and there is not yet a more clear way, using Pod or Python. The one I researched about, a person was just removing negative images, of which I didn't have any negative images. Then I managed to create a model using Python to demonstrate a heat map, as I told you before, that can remove birds. This heat map is based on object detection and motion of people. Then I implemented using OpenCV libraries, and I have different functions, i.e. one that captures the videos using my webcam, and another one that filters the background. So I even used OpenCV library for hack cascades and front office. So the rest, such as box plots, could not be implemented on my data since it is an image. I cannot. That one is more better for analytical data sets. I wrote a Python program that could enable me split my data set into training, testing, and validating my AI. Then for selection and optimization, I preferred using neural networks. So this is a type of deep learning model that are widely used for image classification and object detection tasks all over the world. They are well suited for these tasks due to their ability to automatically extract features from images and learn complex patterns. So the parameters used by CNNs, these are convolutional layers responsible for extracting features, pooling layers to reduce the spatial dimensions, then dense layers to make final predictions, then hyperparameters used to tune CNNs, filter size. The size of the filters used in the convolution can affect the performance of the model. The smaller filters capture local patterns, while larger filters capture more global patterns. Then stride determines how the filters move over the input data, number of filters, the number of filters used in each layer. which can affect the number of features extracted and the complexity of the model. So that's all about that. Then AI selection accountability. We have what is the accountability of this surveillance camera? So what is the responsibility of the AI systems to ensure that they are fully functioning according to what they are accounted for? That is what they're asking for. So in this context of an AI surveillance camera project, AI accountability will involve ensuring that the system is being used for legitimate purposes such as public safety or security, and not for unethical purposes such as racial or gender discrimination. Yeah, so that's all. So my AI surveillance camera is looking at security, nothing like gender discrimination. So it is accountable. Yeah. So for one approach to AI accountability in such a project would be the use of explainable techniques, such as local interpretable model agnostic explanations that can explain it. Yeah, I can give you more brief. The way you see YouTube has a checker. A checker, when you're posting a video, it will check, is it for kids or for adults? So that's accountability. It is accounting for those videos that belong to the kids and those videos that belong to the adults. So that's all. We talk about the metrics, the evaluation metrics I'm using. I have the accuracy to show that my project is accurate, 99% or 100%. So the recall, my AI project should have a higher recall, by the way, because it has to recall the people it saw before, then it can relate with the data set it was trained with. Then for precision, something different. Precision looks at it measures the model's ability to correctly identify the positive instances. So for it, let me say, suppose I was building a project like cancer project, that's when I'll need more precision, because it has to determine the specific disease, which is cancer. So if I'm determining my F1 score, because F1 score is the ratio of precision and recall, I'll give recall a more ratio than precision, a more percentage than precision when I'm developing my AI surveillance camera or something related to recalling. But for determining the best value, I'll use precision, because I have to know that this disease is the one I want, and it is the one that has to be found. Yeah. So that's all I can explain on this. Then the future works emphasize the importance of high quality data. The accuracy and effectiveness of the AI surveillance camera should depend heavily on the quality of the data, provide resources for obtaining data sets, support for data processing, technical support for algorithm development. Yeah, so we consider the scalability. As the camera's use grows, the amount of data it collects and processes may increase. So requiring increased technical support and resources. Encourage the developers to consider scalability in the design and implementation of the camera system and plan for the future technical support needs. These are the links. Link to my notebook where you can go and check out the code and improve if you can. Then my dataset link is there. Then these are the references. Thank you.